Hi, my name is Raymart Bicabajes, a BEC student of Surigao State College of Technology. With my team, we are here to present to you our final project study entitled Prototype Design of One-Story Amphibious House Using Container Van. Due to climate change and global warming advances, level of sea rises gradually, which leads to heavy rain, flooding, and other natural disasters. Therefore, there is need to adopt effective countermeasures against these disasters, especially flooding. So, flooding is one of the most common natural disasters, especially in the Philippines. And this phenomenon has been worsening due to global warming condition. Through this, the researcher developed amphibious house made up of container van that used to adapt flooding rather than creating obstruction. So the conceptual framework of our project study. The conceptual framework of this project study begins with gathering initial data from floodplain dwellers as well as to some professionals whom asked and interviewed to gather information needed. Then followed by the design. Then after the design, in designing phase, we consider the 2D model, the 3D model. So all of that are being considered. And after designing is the prototyping. So here in prototyping, we used to make a miniature of a amphibious house. And after that, after making the miniature, it follows by evaluation. So in evaluation, uh, we test the miniature whether it functions or not. If the hypothesis does not meet, so there is a review and updation for the miniature or for the solution. So we need to back to design and prototyping again, then evaluation. Then it follows for satisfactory. So it if it already satisfies the hypothesis, so it goes now for development. Then followed by testing, and if it delivers another successful result, so that's the time that we're going to maintain the solution. Objectives. So the general objectives for this research is to develop amphibious house system made up of container van, which can float during flooding by using lightweight materials and special designed concrete hull buoyant foundation system that serve as the total buoyancy of the structure during flooding. So specifically, it attempts to achieve the following: to analyze and evaluate the buoyancy and hydraulic reaction on amphibious house system, to design a floating system for amphibious house for flood mitigation, to develop a prototype design of amphibious house system, to determine the economic feasibility of the structure. So in methodology, applied research design is used in this project study. Hence, the proponents are dealing with environmental concerns and are trying to solve using innovative solutions in the form of prototyping and later on applied in real life situation. So what is prototyping? So prototyping is a systems development method in which a prototype is built, tested, and reworked as necessary until an acceptable outcome is achieved, from which the complete system or product can be developed. In doing this type of research design, the researcher attempts to determine or predict what may occur. So presenting to you our project design. So as what we can see here in this figure is a conceptual map of amphibious house.
Good evening, everyone. My name is Sunny C. Olpus, a BEC fifth year student at Surigao State College of Technology. At this time, we will continue to discuss project development. Project development, uh, there are 4 pieces. First piece is analysis piece. The opponent gathered data to the area were prone to flooding, and the data collected was being analyzed in order to come up with a strategic solution to address the problem. The design phase, the opponents are subjected to adapt plans that serves as a guide in developing a structure. Next, the development phase. In this phase, the proponent evaluate the output based on the two pieces, which is analysis and the design phase. Um, here is the analysis. In the analysis, there is survey questionnaires and a site visit. During a site visit, we gather a data by an interviews. We cop up 50 respondents, and 18 of 18% of this is um, encounter only once in a year, and the 78% of this is encountered 2 to 3 times in a year, and the 4% is encountered 4 to 5 times in a year. Then in the design, it includes all the structural the plans of a structure, which is the elevation and the floor plan, or the other structural drawings. In the design, we we uh, we include buoyant foundation. In the buoyant foundation, we design a concrete ponton, a lightweight concrete ponton, and in the swallow foundation, it includes the column footing foundation, the concrete, and the concrete column and the steel column. This figure represents a roller moving up and down during the flood occurs, and to avoid the purpose of this roller is to avoid uh, this to avoid dislocation of a structure.
So based on our results and discussions, so the team came up with the desired end product. So as we can see here in the figure, so in the left side figure, we can see that the amphibious house is set under any circumstances. And then in the right side figure, so the amphibious house start floating when the water level rises. So the mechanism of the amphibious house is that during normal non-flood conditions, this house will rest at the ground surface like typical houses, but with the flood came with enough water to elevate the house through buoyancy system. At the base of the container van enables the structure to float vertically. Upon the rising and falling of the structure, a roller is installed between the container van and steel column so that it would give smooth transition in the mechanism of rising and falling of the structure. So based on the mechanism of the amphibious house, uh, the so we design a roller or we installed a roller between the structure and the vertical guidance post system. So the roller gives a smooth transition between the structure and the post column as it floats during during flooding, and also uh, it will back to its normal position when the flood is descent. The analysis and computation. So uh, we calculate the total weight. We calculate the total weight of the structure excluding the buoyant foundation. So according to our analysis, so we calculate the total weight of the structure to be 243.2 kilonewton, or that is 24,320 kilogram. So in order to design the buoyant foundation, we first calculate the weight of the structure. So the in order to uh, in order to uh, design the concrete ponton or the buoyant foundation that will be used in the amphibious house in order to float. So we assume that the mass of the concrete ponton will be greater than to the mass of the or will be greater than to the mass or to the weight of the structure. So the weight of the structure is 24,320 kilograms. So we decided uh, to assume the mass of the concrete ponton to be 25,000 kilogram. So in order to calculate the volume above the surface of the concrete ponton, so first is, and also to calculate the total volume of the concrete ponton is, first is we calculate first the fraction above the surface. So in order to solve that, so the formula is density is fraction above the surface is equal to the density of the liquid minus the density of the object over the density of the liquid. So based on the code, the density of the liquid is to be 997 kilogram per cubic meter, and the density of the object is to be 500 kilogram per cubic meter. So this density, this 500 kilogram per cubic meter is the density of the lightweight concrete. So in order to solve or to calculate the volume of the concrete ponton, so we use the formula of density. So density is equals to the mass over volume. So volume is equals to mass over density. So 25,000 over 500 is equals to 50 cubic meters. So this is the total volume of concrete ponton. And then we calculate the volume or the change in volume above the concrete ponton. So the formula is the density of the liquid times the total volume. So in order to so we calculate the change in volume above the surface. So 0.4984 times 50 is equals to 24.92 cubic meters. So this is the volume of concrete ponton above the surface. So we have a question. So can the structure be able to stable in a concrete, or will the weight of the structure cause the concrete ponton to sink? Based on the principle of the buoyancy, so the so based on the principle of the buoyancy, if the density of an object is less than to the density of liquid, so the object will float. So we have here change in buoyant force is equals to the weight of the displaced liquid, which is weight is equals to mass times gravity. So therefore, the weight of the displaced liquid is equals to the mass times gravity of the liquid. And mass is equals to the density times volume. So therefore, uh, density of the liquid times the change in volume of the liquid times gravity. So this is the change in buoyant force due to the structure's weight. So this uh, equation is derived from the principle of the buoyancy. So for the structure to be stable above the water and float. So therefore, the change of buoyant force will be greater than or equal to the weight of the structure. So in order to the structure to be stable above the water and to float, so the change in buoyant force is greater than to the weight of the structure. So therefore, we use the formula change in buoyant force is equal to the density of the liquid times the change of volume of the liquid times gravity, and then the weight of the structure is equal to the mass times gravity of the structure. So uh, we calculate, so therefore that we conclude that the change of buoyant force is greater than to the weight of the structure. So it is 24,845.24 kilogram, which is the change of buoyant force, greater than to the weight of the structure, that is 24,320 kilogram. So therefore, the structure uh, will float and be able to stable in a concrete ponton. And also, the additional concrete ponton above the surface can support an additional 24,845.24 kilogram, which is greater than to the weight of the structure. So therefore, the structure will be stable above the concrete ponton and it can float. So we calculate the dimension of the concrete ponton. So in order to calculate that, so we use the volume formula of the rectangle. So length times width times height. So we assume that the length and the width is equals to the floor area of our container van. So length is equals to 9.6 meter and width is equals to 6.1 meter. So therefore, height will be equal to 0.9 meter. So therefore, the dimension of our concrete ponton is 0.9 meter by 9.6 meter by 6.1 meter. So, so we also designed the septic tank and the water harvesting. So we assume that the mass of our both tanks is equal to 5,000 kilogram. So in order to calculate the volume of our tank, so volume is equals to the mass over the density. So the density of the lightweight concrete is equals to 500 kilogram per cubic meter. So 5,000 kilogram over 500 kilogram per cubic meter is, so that will be equal to 10 cubic meters. So therefore, this is the total volume of our septic tank and the water harvesting. So next is we calculate the dimension of both tanks. So same principles of the uh, same principles of of calculating the volume of the concrete ponton, which is length times width times height. So therefore, we assume that the height will be equal to the height of the concrete ponton. So therefore, height will be equal to 0.9 meter and width is equal to 3 meters. So therefore, we calculate the length is to be 3.7 meter. So therefore, the dimension of our tanks is 0.9 meter by 3 meter by 3.7 meter. So conclusions. Based on the results of the design and prototype modeling of amphibious house system, the proponents found out that the amphibious house was functional in the case that it floats and the buoyant foundation beneath the base of the prototype model provides buoyancy to the whole system of the amphibious house. So the proponents concluded that that designing amphibious house must consider first the weight of the structure, hence stability and safety of it refers to the fixed steel column and roller installed. Lightweight materials must be considered also for it will benefit to the structure, economic, cost, and functions. A buoyancy system beneath the house displays water to provide flotations as needed. and the vertical guidance post system provided with roller allows the smooth and firm rising and falling of house to return to exactly its original position upon descent. And then recommendations for the future development and betterment of this study. The proponents recommends the following: study of amphibious house, study of amphibious community along floodplain dwellers all over the Philippines. With this study, it will help floodplain communities to adapt with flooding environment and creates a friendly way of alleviating floods. Then design of a two-story amphibious house so that it will be more spacious and it will be more challenging in terms of designing its buoyant foundation and access to seismic analysis since it is already a two-story structures. And then these are our references. So that's all, and thank you. Thank you for listening.